another section for you. We want to talk about calculating the domain when you have a radical function composed with a rational function. So basically fractions inside square roots is often, if you look to the right, there's an example of one right there. Now, to be able to do this, you really need to know how to solve rational inequalities. Okay, so if you haven't watched the video previous to this one on quadratic and rational inequalities, you got to go back and watch it. I mean, you may be able to watch this and get enough out of it to do it, but if you don't understand, it's because you're not comfortable with the prerequisite material. So here we go. To find the domain, if you have a radical, i.e. square root, cube root, fourth root, we're going to stick to square roots, composed with a rational, i.e. fraction, all right? If you have that situation, step one, if the expression has a variable in the denominator, set the denominator equal to 0 and solve. These values must be removed from the domain, okay? If the expression has an even radical, the radicand expression inside the radical must be positive or greater than or equal to 0. If you have a polynomial or an odd radical, like if this was a cube root, a fifth root, a seventh root, if you have this situation, the domain is all real numbers. And so I haven't noticed in the homework, and I don't do it on this video, where, I don't think I do, where you have that situation. We're sticking to this situation right here. If the expression has an even radical, like the one to your right, it is square root, so we know there's an implied 2 right there, which is an even number. What's underneath the radicand, so let me highlight the radicand for you. That's this stuff right here, basically without the square root. The radicand must be greater than or equal to 0. That's what positive or equal to 0 means, okay? So what I'm going to do is I'm going to set the stuff underneath the radicand, x minus 3 over x plus 1, to greater than or equal to 0. Now I can stop the video right here and go, okay, there you go. Now refer to the last section, because that's really what's happening. So we set x minus 3 to x plus 1 greater than or equal to 0. I'm going to solve this. Now, what I don't want you to do is multiply both sides by x plus 1. If this were an equals, you could do that. But you can't do that here. Remember, the rule is you draw yourself a number line, and any value that makes the denominator 0, which would be x equals negative 1, and any value that makes the numerator 0, which would be x equals 3 in this case, you put on that number line. So here's negative 1, here's 3. Here's the deal, though. From the denominator, it cannot include that value, so hence the open circle. In the numerator, it depends on what the inequality is. Now, if you're finding a domain, that inequality is always going to be greater than or equal to 0, so you can include the 3 because of the equal to part. You with me? And this is the last video that I'm referring to, is all the stuff I'm talking about right now. So if you watched the last video, you already know this. From a denominator, it's open. From a numerator, it's filled in if that's an equal to, which it will be in this section. Now you test points. So I'm going to plug in x is equal to something to the left, like negative 2. Then I'm going to plug in something from the center, like 0 in this case. And then I'm going to plug in something from the right interval, for example, 4. What am I going to plug it into? This guy right here. Because what I'm trying to do is determine if that highlighted expression is true or false when I substitute in for x. Okay? Here we go. We got negative 2 minus 3 in the numerator, negative 2 plus 1 in the denominator. That must be greater than or equal to 0. Well, let's find out. Negative 2 minus 3 is negative 5. Negative 2 plus 1 is negative 1. Negative 5 over negative 1 is positive 5. Is that greater than or equal to 0? It sure is. Now, tricks is you can really ignore the value and work with the signs. In other words, I could have just focused on the top number is, the top number is negative. The bottom number is negative. A negative divided by a negative overall gives us a positive result, and positives are greater than or equal to 0, which means I shade where that test point came from. It came from the left, a number less than negative 1, so I shade that in. Now I'm going to plug in 0 with the same analysis. So 0 minus 3 over 0 plus 1. 0 minus 3 is a negative number. 0 plus 1 is a positive. A negative divided by a positive is always a negative. Are negatives greater than or equal to 0 No, they are not ever greater than or equal to 0. So the middle is false. When I plug in 4, I have 4 minus 3 over 4 plus 1. 4 minus 3 is a positive number. It's 1 if you want to be precise. 4 plus 1 is a positive number. It's 5 if you want to be precise. Is 1/5 greater than or equal to 0? Sure. Is a positive number greater than or equal to 0? Sure. So you can think about it either way. Either way, it is a true statement, so I shade in that side. Now what? Well, the domain is that interval. So the left side is negative infinity to -1 with a parenthesis, because the -1 is not included, union with a bracket around the 3 to infinity. And that's how you find the domain of rational expressions composed with radical expressions. Okay? All right, let's try this again. So example B, I give you, again, a rational expression composed with a radical expression. Okay? And it says, if the expression has a variable in the denominator, set the denominator equal to 0 and solve. These values must be removed from the domain. Basically, I'm taking my expression, x plus 4 over x minus 5, and that thing better be greater than or equal to 0. Okay? Now, to do this, because it's an inequality, I need a number line to help me out. You cannot just solve this like this is an equals. That will not work, ever. The number line is the way to go. What goes on the number line are the values that make the denominator equal to 0. So you set x minus 5 equal to 0. That gives me x equals 5. So I need to put 5 on my number line. The values that make the numerator equal to 0, I set x plus 4 equals 0. That gives me x is equal to -4. So I need -4 on my number line. It is a number line, so they have to be in order. -4 definitely comes before +5. Anything from the denominator, the 5, cannot be included. Values from the numerator can be included, and the reason they can is because of the equal to part. Why is the equal to there? Because that's the domain of a even radical. It's always, what's underneath is always greater than or equal to 0. Now you test points, so I'm going to plug in -5, because that's something in the left-hand interval. 0 is something in the right-hand interval, and 6 is something on the, middle interval, and 6 is something from the right-hand interval. I'm going to substitute that into this highlighted expression I have right here. Okay, so when x is -5, I have -5 plus 4 over -5 minus 5. That gives me -1 over -10, which is a positive number. That is greater than or equal to 0. That's true. Okay, when I plug in 0, I have 0 plus 4 over 0 minus 5. That's positive 4 over -5. That's -4/5. Is that greater than, almost flipped it around, or equal to 0? That is false, so I do not shade that in. In the last one, I have 6 plus 4 over 6 minus 5. That's 10 over 1. Is 10 over 1 greater than or equal to 0? It's true, so I shade that in. So my answer is -infinity to -4 with a bracket, union, parentheses 5 to infinity. That's the domain. What does domain mean? It means the values you are allowed to plug in that function. Notice, I couldn't plug in anything from the middle. If I did, so for example, if I plug 1 in up here, that'd give me the square root of 1 plus 4 over 1 minus 5. Well, that's 5 over -4, which is a negative number. You cannot take the square root of a negative number. See what I mean? So you're trying to find out what you're allowed to plug in that function. Now here we have the same story, but a slightly more complicated radicand. But the idea is the same. I have a square root, so I'm supposed to take that square root, whatever's underneath, and set that to greater than or equal to 0. That's the inequality I'm trying to solve. So I draw my number line. And remember, what goes on my number line is anything, any value that makes that my denominator or numerator equal to 0. So from the denominator, x equals 3 would go on there, x equals -2 would go on there, and x equals -5. Now some of you are having that thought, oh, it's just the opposite. Well, yeah, because I'm setting x minus 3 equal to 0 and solving and getting x equals 3. I'm setting x plus 2 equal to 0. That gives me negative 2. You see what I mean? So I'm really setting each one of those equal to 0, but I'm saving us all some time and space by just writing it like that. Now, all three of these numbers go on the number line in numerical order. So negative 5 must occur first, negative 2 is next, and then positive 3 over here. I'm not worried about the spacing. I know that is not correct spacing. Don't care. I'm just trying to get them on my number line in order. Now, any value that comes from a denominator, so 3 and negative 2, they need to be open circles because we cannot have those values, plug them in my expression, because it's going to give me a 0 in the denominator. Remember, that's big time not allowed. Now, from the numerator, a 0 in the numerator is fine. As a matter of fact, you just refer to your inequality for that. If there's an equal to there, then that can be equal. Okay? Now, my next step is to test points. So I'm going to pick values, some value that's left of negative 5, like, for example, negative 6, some value between negative 5 and negative 2. So let's say negative 3, some value between negative 2 and 3, 0, and some value bigger than 3, for instance, 4. Where am I going to substitute that in? Right here. Okay, I'm going to try to determine if that's true or false. So if I take negative 6, that'd be negative 6 plus 5 over negative 6 minus 3 times negative 6 plus 2. Now, you can actually do the calculation, but if you just work with the signs, it's faster. Like, for example, negative 6 plus 5 is a negative number. In the denominator, negative 6 minus 3 is a negative number. Negative 6 plus 2 is a negative number. Now, overall, a negative divided by a positive is a negative. Is a negative greater than or equal to 0? It's not. So I do not include that. Okay, so you can save yourself a lot of stress, at least a lot of brain power, and not actually do the calculation, just work with the signs. So I'm going to do negative 3 the same way. If I have negative 3 plus 5 divided by negative 3 minus 3 times negative 3 plus 2. Now, negative 3 plus 5 in the numerator is a positive number. Negative 3 minus 3 is negative. Negative 3 plus 2 is also negative. A positive divided by, this is a positive, right? Positive divided by a positive is a positive. Is a positive greater than or equal to 0? It sure is, so I shade this interval. Same thing with 0. 0 plus 5 in the numerator, 0 minus 3 times 0 plus 2. 0 plus 5 is positive in the numerator. 0 minus 3 is negative in the first parentheses. 0 plus 2 is positive in the second parentheses. Now, a positive divided by, this is overall a negative in the denominator. A negative times a positive is a negative. Positive divided by a negative number is always a negative number. Are negatives greater than or equal to 0? They are not. This is a false statement, just like the first one was a false statement. Okay, so I don't shade that piece in. Finally, I'm going to plug in 4. 4 plus 5 in the numerator. 4 minus 3 times 4 plus 2 in the denominator. 4 plus 5 is positive. 4 minus 3 is positive. 4 plus 2 is positive. Look at all those positives. A positive divided by a positive is a positive. Is that greater than or equal to 0? Sure. That's what greater than or equal to 0 means, is that it's, well, greater than 0 means it's positive. Equal to 0 means 0. That is true, so I shade that in. Now, I have to write this in interval notation to get it right. So I'm writing down in interval form what I have shaded. Well, on the left, it starts at negative 5 and it ends at 2. At negative 5 is included because of the filled in. So I'm going from bracket negative 5 to negative 2 that's not included. Union, parentheses around the 3 because it's also not included, all the way to infinity, and infinity always has parentheses. And there's your domain. So if I were to graph this, which we are not, don't worry, we are not in this course, but if I were to graph that, these are the only numbers I could plug into that function. It also means there's only a graph between negative 5 and negative 2 and 3 and infinity. There's not a graph for this anywhere else because you don't get real numbers when you plug into the expression. All right, these are the last two problems that I want to do, and notice I have a versus in the middle. what I want to do is compare these two problems. If you look at the first one, the square root is over the entire expression. So what I set to greater than or equal to 0 is x minus 1 over x plus 2 times x minus 5. I set that whole expression to greater than or equal to 0. Versus this guy over here. The only thing that's under the square root is the x plus 2 times x minus 5. Now, normally I would set that greater than or equal to 0, but it can't equal to 0 because it came out of the denominator. So I'm just going to set it strictly greater than 0. And again, the reason I don't have the equal to here is because that came straight out of a denominator. Now, what if you accidentally wrote down the equal to? That's fine, but when you shade it, it still can't. It'd have to be open circles because it came out of the denominator. And now you're also thinking, well, what about the x minus 1? Well, the x minus 1 is not under a square root. Therefore, we don't have to worry about whether that's positive or negative at all. It's not under square root, so it can be anything it wants to be. Okay? So on the left, when I solve that, remember, numbers that go on my number line are whatever makes the 0. So you want to write it down because you might not get the order right if you don't write it down somewhere. Like, negative 2 is the smallest value, so there's negative 2, and then the next smallest is 1, and then the next is 5. Notice I don't have these in spaced properly. Don't care. What matters is that they're on my number line, so I know what points to test, and it also helps to know whether it's a filled-in circle or not. So at negative 2, it came from the denominator, so it's open. 1 came from the numerator, so that means 0 is equal to 0 is okay. 5 came from the denominator, so it's open. And then I test points like I've been doing all along. So I'm going to test x equals negative 3. I'm going to test x equals 1. I'm going to test x equals 2. And finally, x equals 6. I'm going to try to write this small enough to get this done. So when I plug in negative 3 up here, now look, I'm going to save us some space and some time. This is what I'm working with, right? Now hang with me. Not stop, rewind, whatever you got to do. I'm plugging in negative 3 up here. When I plug in negative 3 minus 1, that's a negative number, right? When I plug negative 3 into this first set of parentheses, negative 3 plus 2 is a negative number. Negative 3 minus 5 is a negative number, okay? A negative divided by a positive overall is a negative. Is a negative greater than or equal to 0? No, that is a false statement. Therefore, I do not shade that piece in. See how I save us some time and space? Now I'm going to do the same thing with 0. When I plug 0 in the numerator up here, 0 minus 1 is a negative 1. It's negative. When I plug 0 in into x plus 2, that's positive. When I plug 0 into x minus 5, that's negative. A negative divided by overall a negative is a positive. Is a positive greater than or equal to 0? Yes, it is. So I shade that part in. Now I'm going to substitute in 2. Again, keep in mind what I'm doing. I'm taking the 2 and I'm plugging it in to the highlighted aqua area for every x value. So when I plug 2 in the numerator, 2 minus 1 is 1, but what I care about is that it's positive. 1 is a positive number. 2 plus 2 is 4. What I care about is 4 is a positive number. 2 minus 5 is negative 3. What I care about is minus 3 is a negative number. Now if you take a positive and divide it by a positive times a negative, which is a negative. So this is a positive divided by a negative overall answer. It's going to give us a negative. Now, are negatives greater than or equal to 0? They are not. This is a false statement, so I do not shade where the 2 came from. Now, please don't just go, oh, it's alternating. It might be. It might not be. Be careful. Now, there are ways to determine if it's alternating or not, but we're not going that deep into it. This is the trick. What I'm showing you is the trick right here. Just take points and plug it in. So if I take 6 and I plug it into the highlighted area for x, so 6 minus 1 is positive. 6 plus 2 is positive. 6 minus 5 is positive. Now positive divided by this is a positive is overall a positive. Is a positive greater than or equal to 0? Sure is. That is a true statement, or I could use my check mark like I did before, and that means this gets shaded in. So my answer, I'm going to do the final answer in black up here, is what's shaded in. So parenthesis -2 to 1 with a bracket, union parenthesis 5 to infinity. Now what did we find? We just found the domain of this function. That is the domain. That's what we're finding in every single problem in this video, is the domain, what we are allowed to substitute into that function. Now for the next problem, I wanted us to compare, and we really have already compared, because the whole fraction was underneath the square root here. I set the whole fraction to greater than or equal to 0. But over here, the only thing that was underneath the square root is just the denominator. Therefore, I set it greater than 0. Now remember, what goes on my number line is when I set these equal to 0. So -2 and +5 is all that goes on my number line. The 1 I don't have to worry about. And now I'm picking points to test. So here, x equals -3 I would test, x equals, say, 0, and x equals 6. Where am I plugging that in? I'm plugging it into my inequality, right here, okay? All right, so here we go. I'm going to take -3 and plug it in here. -3 plus 2 is a negative number. -3 minus 5 is a negative number. A negative times a negative, is that greater than 0? And it is. A positive is greater than 0. So that checks, or it's true. So I shade in where the -3 came from, which is right here. By the way, I forgot to put my open or closed circles. Remember, this came from a denominator, is one way to look at it. Or there's strictly a greater than, is another way to look at it. Either way, those are open circles right there. It's the only way to do it. Now we'll take 0 and plug it in my highlighted up here. So 0 plus 2 is 2, which is a positive number. 0 minus 5 is -5, which is a negative number. And when you multiply a positive times a negative, we always know that's a negative. Is that greater than 0? That's a false statement. That is totally not true. A negative is never greater than 0. So therefore, I do not shade that piece in. Then finally, I take 6 and plug it in. 6 plus 2 is 8. What matters is it's positive. 6 minus 5 is 1. What matters is that that's positive. All right. A positive times a positive, is that greater than 0? Yes. Yes, it is. That is a true statement, so I shade that in. Now, my interval, or my final answer for this domain, is what's shaded in. So we're going from left to right. Negative infinity, and then at -2 it stops. Also at -2 it is not included, so I need parentheses. The next piece doesn't start until 5, but it doesn't actually start at 5, it starts just after 5, by the way, which is not 6. There are an infinite number of numbers between 5 and 6. So it starts just after 5, which is what parentheses mean, and it goes all the way to infinity. So the domain of this function, okay, is -infinity to -2, union 5 to infinity. I hope this helps. I hope you have a wonderful day, and come back for the next videos.